Hello everyone, my name is Andy, and I would like to present to you the team behind the Goalplay app Video Coach. So our customers are Christian Prodaniuc and Samuel Roth. Our project leader was Juan, and our 6 amazing developers who've been working very hard for the past 7 weeks are Kerko, Andach, Ewan, Marie, Sami, and Jonathan. And now I would like to invite Ewan to the stage to explain more of the problem that goalkeepers are facing today.
Thank you, Andy. So let's first take a look at our problem. We all know that the goalkeepers, instead of kicking the ball all the time, they are the only ones who are allowed to use their hand to touch the ball. That is why they need special training. But the truth is that nowadays, the coaches in normal teams, especially amateur teams, they know how to teach people to kick the ball very well, but they cannot teach the goalkeepers to do a better dive or a better catch. That is how the goalkeepers start to struggle without enough feedback from their coaches. And with this, we're developing our goalkeeper virtual training app so that the goalkeepers can use our app to record their training sessions and receive feedback automatically generated by our app. Simple. So in order to do this, we identified 3 functional requirements for our app. Firstly, we need our app to be able to record the training of the goalkeeper, and then we need to use our app to analyze the videos that we captured. We need to detect the motion in the videos, and also to recognize the exercises that the Go players executed during the training. And last, we need to generate statistics and feedback so that the goalkeepers can know how and where they can improve in the future. In addition to this, we also have 3 non-functional requirements for our app. Firstly, our app should work at appropriate camera location on the field so that the cameras won't be broken easily or they will interrupt the training that's just happening nearby. Also, we need our recognition to be robust, which means they can work at any weather condition and also under any camera resolutions. At last, we need our app to be energy efficient so that we won't lose the data in the middle of the training. We need to record the training session from the beginning to the end, and we analyze them afterwards. With that said, let's take a look at our trailer.
Team, probably next time you will do it, okay?
It's alright, Tim. Don't worry. You'll make it one day.
Thanks, Dad.
I have the perfect tool for that. The Goalplay app.
Now I'm going to show you how we formalize this problem. Our goal is to support the goal player to improve his skills. During the training sessions, the goal player performs several exercises like dives right, dives left, catch the ball. Our system should record these training sessions and automatically analyze that videos records to generate statistics. These statistics can be for one single training statistics or aggregated over time. And finally, based on these statistics, feedback is generated and then provided to the goal player to improve his skills. And now I'll hand over the stage to Sami to show our system.
Thank you, Andach. Now that we have formalized our problem statement, or problem domain, we want to describe how we want to solve it, the system we designed. But instead of showing you the whole system at once, let's take a look back at our analysis object model and start to show you how we transferred the entities to our subsystems. Therefore, we decomposed our model into subsystems and then started to replace single or merge entities and replace them with the corresponding components. After we did that, we are going to relocate the subsystem and add the association between the components. Now that we have our whole subsystem here, we can see that we have 3 subsystems, which are profile, which is going to contain and maintain our user informations, our recording subsystem, which is going to record the training session and provide the videos for the analysis part. And as the last, we are going to give over the data over to the virtual coach, which is like a real coach going to generate statistics based on observation and provide, based on that, feedback to our goal player. And that will look like this. And now we have to add one more subsystem, which was not explained in the problem domain because it's just part of the solution domain, which is our activity recognition. It uses the provided video data to collect those information and prepare them such that we can classify different exercises and provide those observations for virtual coach. Since that's a very important part of our whole system, and Jonathan is now going to focus on that and explain it in very detail.
Thank you, Sammy. If we take a look back at our NASA's object model, the training session, during a training session, the goalkeeper performs different exercises. For example, the dive left or the dive right. These are also the exercises we are focusing right now to get started with the classification. But how do we actually classify it? So our input is video frames. We just get video frames and we feed into some kind of model and then we get as an output the exercise. One option would be use an end-to-end sequence model, could be like a convolutional neural network with a recurrent neural network, but this requires a massive data set. And we are not BSH, we don't have 60,000 employees, so we can't do this. So we have to extract features beforehand. For this we use post-estimation. Post-estimation is a field of research where a lot of research work on that, where you just feed in images and you get the body key points out. And now we have reduced our input from a couple of millions of pixels to just a few image coordinates. And now it's way easier to train in a model. We can even use a rule-based system. We can just use math and simple logic to classify exercises. But it gets complex the more exercises you add. So if we use an ML-based model, we don't need a big data set, and we need not a lot of computing power as well. So this is totally feasible. For example, for a rule-based system is we just take the image coordinates of the body joints, we just take the body center to even out some movements, and then we just take a look at the change in the x direction to the left or the right, and then we can classify dive to the left or the right. This is exactly what we did for the live demo right now. So we're going to start with the UI first. So this is the home screen. You see your last training sessions, as well as an inspirational video of Oliver Kahn. On the statistics page, you see your aggregated statistics over time, so you can see how you improved over the period. And now the exciting part, the exercise classification. I would like to invite Marie and Anders on the stage. But to make sure we cannot mock this classification, we would like to ask you, Professor Brügge, to tell us a direction where we should aim to. Okay. Left or right? Center. Center is not possible, sorry. Left. Okay, so we throw the ball to the left.
So from your side, right.
So we throw to the right.
From my point of view, left.
Okay, we throw it to the left. So we just hit start workout, and now we are in the camera view. Now I start recording. Now Anders can throw the ball. Great save, Marie. Now we just say use video, and it should successfully classify a dive to the right. And now, no, but from her perspective, okay. Okay, so if we go back, we could also see, we can see an overview of the sessions and see the training log. All right, now we take a look at our status. So in the start, we started with just getting familiar with Core ML and doing recordings with the camera. So we just built a simple image classifier for flowers. and then we did combined it with the post-estimation we did later on. Then we start with the rule-based exercise prediction, and we're successfully able to do it. Next up, we try to do with machine learning, but we need the data for that, and we're still working on that. And we will improve our statistics and support more exercises later. And then the client acceptance, we hopefully will be able to classify a whole training session. I want to thank the customer. Thanks for support so far, and we're looking forward for the next week. And thank you. Are there any questions?
First of all, yeah, thank you very much for your effort for the first part of the project. It was really fun to see. Also that you have had a good time at the playground at Bad Aibling, what I heard of. Also, I know that it wasn't easy to get the algorithms running on the smartphone, so that was really impressive that you could get so far by now. So congratulations, and I'm looking forward to see more next time. I have two questions. First question, where did you get that goal from? It was really awesome. And the real question is, so for the next steps, would you rather now focus on like maybe one exercise like the dives and just specify in detail to optimize the detection of this exercise, or would you rather suggest to just try to have a wider range of exercises to detect, because actually that are two different approaches, right?
Yeah, okay. So first the goal was from the basketball field over there. And so the second question, so the rule base is probably not feasible to do too many exercises, or the system will be really complex, and a machine learning approach makes more sense. But we have to see how far we get, how good our data set will be, and then we have to iterate over and see what approach works best for us.
All right, thank you.
Thank you.